All right, when I did the Google form, I did set 21 up incorrectly. This one is going to have three answers. I think on the form that would only let you pick one, but there are three answers. So what we have is a graph of the velocity of an automobile as a function of time, and we want to know which graphs is this automobile not accelerating. So not accelerating is going to be decelerating, which are answers B and E, and when the velocity is constant. So the answer should be B, E, and C. All right, for 22, we're going to use our calculator to figure out what values of x this graph crosses the x-axis. So we'll go to y equals and type it in and check out the graph. All right, so one of them is one of the first three, and it's not 5 or -5, but halfway between 2 and 3 is going to be 2.5, the positive side. All right, and then the other one is over here at -3. Now, if you're unsure, that is 2.5. You can pretty much tell that that's -3. You can calculate a zero. So just a reminder, to calculate a zero, it's second, trace, and then number 2. And then you get a little flashing cursor. Right now, it's down at 1 -15. So I'm going to hit the right arrow and move closer to it. But I'm going to stay on the left side of it. I'm going to hit enter and then hit the right arrow, cross over the x-axis, and enter 2 more times. And yeah, that's definitely 2.5. Right, 23 asks, is 2x plus 2, a factor of that polynomial? So we can check that using synthetic division. Now we would want to do the opposite. And then we would bring over the coefficients and the constant. Now we're checking to see if we get a remainder of 0. So we're multiplying and adding, multiplying and adding. All right, I got a remainder of -12. Now there's two answers that have that remainder. And so one of them is yes and one of them is no. We want to choose no because the only way that it is a factor is if you get a remainder of 0. All right, 24, we have this graph. It tells you it's exponential growth. We have a table of values also. All right, and we want to know to the nearest whole organism how many organisms are expected to be in the petri dish at 24 hours. So it's been a while since we've done this, and we have not spent time reviewing it. But what we're going to do is put this in a table in the calculator. So to get that, you're going to hit Stat, and then you're going to Edit. All right. Now, if there's something in your list, you would clear them out. For the EOC, your list will be cleared because we're going to reset all the calculators. All right. So I'm going to put in these values. So do 0, enter, 2, enter. Okay. All right, and then because they told us that it was an exponential growth, we're going to find an exponential regression equation. right? And to do that, we're going to need to quit out of here. All right, sorry, someone knocked on my door. All right, so we're going to go back to stat and go over to calc. And what we're looking for is exponential regression, and it is at 0. So you can scroll up or down to get to 0 for exponential regression, and then hit enter, and then hit enter several times. Okay, so that's my regression equation. I'm going to jot it down. So I'm going to do y equals, I'm going to put 27.03 in for A and 1.15 in for B, and then that's raised to the x. All right, and then we want to use that equation for 24 hours. So we would put 24 in for x. So I get 774. Now there's a whole bunch of answer choices that you get correct for this one. So if you had rounded a little differently, rounded to more places, you might get a bigger number here. There's a lot of them that will be correct. So I think it's like I don't remember, 770 to 800 or something, or maybe even a bigger range than that. Okay, and then for number 25, a piece of heavy machinery for, Calvin purchased a piece of heavy machinery for $32,300. The value of the machine depreciates at an annual rate of 8.3%. Okay, so on your reference sheet, you should have a depreciation formula. Now, it doesn't straight say depreciation, it says exponential decay, but it is the same formula. So the initial value is always going to go right after the equal sign, and then R is going to be your rate, but it does always need to be as a decimal. Now, this is what I would prefer that you guys did on this problem. This is not my favorite question, but obviously I didn't write this test. And they might throw this on there. I just don't think it's that important, so we didn't spend a lot of time on it. So this one looks very similar to A and to B, but it's asking you to find the approximate equivalent monthly depreciation. And so they both have a little bit of something that's different than what ours is. So the answer is going to be the one that if you multiplied them together, you would get T, which is going to be C. If you multiply these together, A, you get 1/12 T. But if you multiply 1/12 times 12T, that just gives you T. So that's kind of an annoying question. All right, for 26, two students work the same problem, Jamie and Taylor. We want to know which person did it correctly or not. So we want to, it's either Jamie is right because of this or wrong because of this, or same thing with Taylor, right or wrong because of this. And so Taylor definitely does it right. Like, I'm not sure what Jamie was thinking. Must not understand about marriage because Jamie canceled those fives and made them ones, but you can't do that because they're married, and so we can't cancel unless there's a couple that looks just like them. So what Taylor did was cross multiply, which is right. And so that should be P. Now, Jamie is wrong, but not wrong in step 2 and 3. Jamie was wrong in step 1. And Taylor is never wrong. All right, let's look at number 27. So we have the graph of a system of equations, and the question is what are the x values for the solution of the system? So there's 2 points where they cross. We only want the x values at that point. So the x value at the first point is 0, and the x value at the second point is 2. All right, 28 is another average rate of change problem. So we want to know the average rate of change between t equals 1.5 and t equals 2. So remember, average rate of change is just the slope formula. Okay, so we don't care about anything else in this table. So I'm going to do 9.6 minus 10.7 over 2 minus 1.5. And your calculator can do that for you. Just lovely. Negative 2.2. All right, on 29. This one, that they just ask you to graph these certain things. You don't have to draw the whole parabola, you just have to graph those. And so we'll go to y equals and plug it in. Okay, and then the intercepts are one thing, the x-intercepts and y-intercept. So we have an x-intercept at -1, a y and an x-intercept at 3. So let's go ahead and graph those. And a y-intercept, it looks like 4. Now, if you're unsure, we can go to the table. Oh, I would have been wrong. It is at -5. So -1, 0 was right. Ooh, I was wrong about the x-intercept too. Okay, we definitely need to go to the table. -1, 0. It was the only thing right of things I said. And so the y-intercept we got from the table was -5. The other x-intercept, we're going to have to calculate it. So let's go to the graph. It's going to be a 0. So second trace 0. We're going to move close to the x-intercept, but we're going to stay on the left, hit enter, cross over the x-axis to the right, hit enter, and then enter again. So that's going to be 2.5, so careful. All right, and then the other things that they asked you to graph were a maximum or minimum point. Now this one doesn't have a maximum. This one has a minimum. So we're going to calculate the minimum by doing second trace 3. And move that little flashing cursor to the left of the minimum. Hit enter. And move to the right of the minimum. And hit enter. And then enter one more time. So it's at 0.75 and then -1.25. So we're just going to guess. Hold on. 0.75 -6.125. Yeah, that was a good place. I don't know why I moved it. All right, and then for 30, each function that has an inverse that also is a function, or select each. All right, so we're looking for the ones that pass the horizontal line test. Right. And then when we talked about this in class, like any linear function that's not a horizontal line, so a linear function that has an x and a y is going to pass. But if you want to look at each one of these individually, you can, just to be sure. You have plenty of time on your test. All right. That one is definitely going to fail. All parabolas are going to fail unless they have a restricted domain. So that's going to be a no. All right. A line is going to pass. R is also a line. It is going to pass. Okay, this one is going to pass. It looks like it's horizontal there, but it isn't. It's rising slightly. If it fails, it's going to be obvious that it fails. Okay, that one obviously is going to fail. Horizontal line would cross two places. So those are all the functions that have inverses that are functions because they pass the horizontal line test. All right, and several of you asked me about 31, and I wanted to talk about this one, and it's something I'm going to talk about on the day we talk about calculators also. But when you have an equation that you can't solve and you don't have answer choices, what you can do is take one side of the equation and put it in for y1. Now, don't use t, make sure you use x, right? And then do the same thing for 12. All right, now you can just see a teeny bit of the graph because it gets so close to the y-axis that you can't really see it, and you can't see it at 12. So if you wanted to, you could zoom out, and you can see the 12 there. It doesn't matter because we're just going to calculate the intersection. So it's second trace number 5, and just hit enter, enter, enter. Ah. So that is we just want the x at that point, and it tells us to round to the nearest hundredth, so that's 0.16. So find the intersection. Second trace number 5.